Hello! Today we are exploring the world of two-dimensional vectors, a key part of the IGCSE syllabus. By the end of this video, you will be able to describe and define a two-dimensional vector using both column notation and geometry. You will also learn how to add and subtract vectors algebraically and visually. Finally, you will be able to multiply a vector by a scalar and understand what that does to its magnitude and direction. Let's start with the basics. What exactly is a vector? In mathematics and physics, we distinguish between two types of quantities, scalars and vectors. A scalar is a quantity that only has a size or magnitude. Examples include mass, temperature, or time. A vector, however, has both magnitude and a specific direction. Think of it like giving someone directions. You don't just say walk 5 meters, you say walk 5 meters to the north. In geometry, we represent a vector as a directed line segment. The arrow shows the direction of travel from an initial point to a terminal point, and the length of the arrow represents the magnitude. We usually write vectors using bold lowercase letters, like V, or by drawing a small arrow over the letter. To work with vectors in 2 dimensions, we use a format called a column vector. This tells us exactly how far to move along the horizontal and vertical axes. A column vector is written with 2 numbers stacked inside brackets. The top number, x, represents the horizontal movement. If it is positive, we move to the right. If it is negative, we move to the left. The bottom number, y, represents the vertical movement. A positive value means moving up, and a negative value means moving down. Let's look at an example. Vector A is 3, 2. To draw this, we start at any point. We move 3 units to the right, and then 2 units up. The vector is the arrow connecting the start to the end. Notice that the vector defines the movement, not a specific starting position. We have successfully met our first objective of defining a 2-dimensional vector. Now that we know what a vector is, let's learn how to add them together. We can do this both algebraically and geometrically. Suppose we have vector A, which is 4, 1, and vector B, which is 1, 3. Algebraically, adding vectors is very straightforward. You simply add the corresponding components. We add the top numbers together, and then add the bottom numbers together. So, 4 plus 1 gives us 5, and 1 plus 3 gives us 4. Geometrically, this is known as the nose-to-tail method. We draw vector A first. Then, we place the start of vector B at the arrowhead of vector A. The result of the addition, often called the resultant vector, is the single vector that goes from the very beginning of the first vector to the very end of the last one. Notice how moving 4 units right and 1 up, followed by 1 unit right and 3 up, is exactly the same as moving 5 units right and 4 units up in one go. Subtracting vectors is just as simple as adding them, but we must be careful with our signs. Let's take vector A as 3, 5, and vector B as 1, 2. To find a minus B, we subtract the components of B from the components of A. 3 minus 1 equals 2, and 5 2 equals 3. Geometrically, you can think of subtracting B as adding the negative of B. A negative vector has the same length but points in the exact opposite direction. So, to show a minus B on a grid, we draw vector A, and then from its tip we draw vector B in reverse. The resultant vector starts at the beginning of A and ends at the tip of the reversed B. We have now mastered our second objective, adding and subtracting vectors, both algebraically and visually. The final topic for today is scalar multiplication. This is when we multiply a vector by a normal number, which we call a scalar. Let's use vector V, which is 2, 1. If we want to find 2v, we multiply both the top and the bottom components by 2. This gives us the vector 4, 2. Notice what happens to the arrow on the grid. The direction stays exactly the same, but the length or magnitude has doubled. What if we multiply by a negative number? If we calculate minus 1 times v, we get negative 2, negative 1. Multiplying by a negative scalar reverses the direction of the vector. An important rule for your IGCSE exams is that any vector that is a scalar multiple of another is parallel to it. Because the ratio between x and y stays the same, the slope of the line doesn't change, only its length, and occasionally its sense of direction. We have now achieved our third goal, understanding scalar multiplication. We have covered a lot of ground today regarding vectors in 2 dimensions. First, we defined a vector as a quantity with both magnitude and direction, and learned to write them as column vectors. Second, we practiced adding and subtracting vectors by combining their horizontal and vertical components. Finally, We saw how multiplying a vector by a scalar changes its length and can reverse its direction, while keeping it parallel to the original. To check your understanding, try this. If vector p is 3, -1, what is the result of multiplying p by 3 and then adding vector q, which is 2, 5? Take a moment to work that out. You should find that 3p is 9, -3. Adding vector q gives a final resultant of 11, 2. Mastering these basics will make more complex vector geometry much easier to handle. Keep practicing, and I will see you next time.